there, and also having a connection to Karolinska Institute.
Yeah.
And she's back every couple of weeks, so you've probably met Ida, if not before, maybe in the last couple of weeks. And we work together on this project, which I'm very interested to hear the most recent changes to. It's on choice and decision making and action observation. Eventually, we'll get to, I think, as well.
Yeah.
So it's part of a string of studies, and it's my pleasure to welcome Ida back again and to hear about the updates to the research. Thank you.
Yeah, and thank you for coming today and listening to this talk. As Josh said, so this is work that we sort of do together, and it's also work that I started here that I will present today. But it's also hopefully one study of many, and I also somehow with this presentation want to invite you, I guess, if you have ideas on what to do, because I would say like the data we can work with, I think it's actually pretty nice. So maybe you have ideas on stuff you think we should do or stuff that you want to do. Who knows? Maybe not. So, and of course now I can't click. Let's see. Yeah. Okay. So most of the research that I've done through the years have evolved around social learning of some form, and of course, social learning is it's a broad form of learning, or it can mean a lot of things, but it enables us to learn from others, right? So we can, for instance, learn to fear snakes by looking at other people being fearful to snakes. We don't have to interact with snakes ourselves. And of course, social learning is somehow the basis for like cultural evolution and accumulation of knowledge and things like that. So it's a very important ability that we have. What makes social learning so valuable? So I Googled a little bit, found this image. I think it's from some sort of a course or slides from a course on cultural evolution. And it says something about, information is passed from one mind to the other through learning. So this somehow shows that in social learning or cultural evolution, we kind of the information that one mind has is transformed to another, and therefore we can evolve and learn, right? And this somehow model of what learning is of course sort of correct in some cases, like teaching, for instance, giving instructions. I don't think this somehow generalization fits very well in all cases. So the fear of snakes example, right, is one of those. So when learning from the mistakes of others is of course not transformation of information from one mind to another. And even when it comes to simple decisions, right, it's a little bit unclear what kind of information is really passed from one individual to another. So this is a study looking at observational learning in bees. So this test bee observes other bees picking the orange color here, and then in the test phase, the test bee has to make his or her own decision, right? And presumably the decision of others kind of reflects some sort of a preference, and you can think of, let's say, a copying behavior, if that's what the bee does, as some sort of a transmission of preference, maybe. So maybe some sort of a transmission of information, like from one bee's mind to another bee's mind. But maybe it's possible that decisions or decision actions can be more informative than we sort of usually assume. So this is a very simple form of information, or lower level maybe. So I'll show you a bomb diffusing scene from Goldfinger. Hope it works. There's no sound, we don't have to hear the sound.
That's a complicated bomb.
Okay, so from this little scene, I thought it was actually a perfect example. We were just talking about how we try to illustrate our ideas sometimes, but it is clear just by, we can just watch what they're doing with their hands, right? Bond and this other guy, I don't know exactly who is. That the knowledge they have of this bomb, or the information that they have, right, they're very different. Bond doesn't know anything, I would say, and this guy knows a lot. And we know that somehow decisional learning processes, or somehow learning related things are expressed in actions. This is not really new. We know that, for instance, decision difficulty affect response times. That's not very strange. Fearful contexts can increase the initiation time during decision making. Post-error slowing is such an effect, sort of learning effect. And of course, we know that movements are sensitive to decision trade-offs, for instance. So speed versus muscular cost, or speed versus accuracy. So. And these are just a few examples. There are many, many others. Like, we know that somehow the circumstances during decision making or during learning actually affects movements or other kinds of reactions. And this could be used, right, in an observational setting. But what is valuable information from an observer's point of view? So what would be the information that we somehow would want to extract when we observe someone making a decision? So this is not an exhaustive list, but during the decision, it could be good to know whether the demonstrator's decision is explorative or exploitative. What the demonstrator's confident in the decision is, maybe what the decision maker somehow expects to happen, or the beliefs that the demonstrator has. Let's say it could be valuable to know whether or not it is a decision to gain something or avoid losing something. Maybe how certain the demonstrator's belief of an outcome is. I mean, there are several possibilities here. And after a decision is made, and maybe the decision maker, something happens, the decision maker eats a candy and reacts in some way, right? And this then the outcome somehow of the decision is not really available to the observers. We have to try to distinguish what happened, right? So whether or not the candy tasted good or bad, for instance. So what happened? What was the outcome? Was it as predicted? Maybe something about what the demonstrator learned could be valuable information. So if we consider this, then the question is, of course, well, can we somehow transmit information beyond just like choice preference by observing decisions of others? We first then have to ask ourselves, well, what information is really expressed then in a decision action? And then secondly, well, is it possible for an observer to perceive whatever is expressed? Do decision actions or like movements that are specific for decision action, can we use them to guide our own decisions? Can we somehow brought like actual transmission? It's a little bit strange perhaps, but like can we really like transmit that information, take that information onto ourselves? Let's say confidence, do we somehow incorporate that or understand that? So this is somehow the main questions of the study I'm presenting here, but we will actually mostly or only focus on this first part because that's kind of where I am in the study. So to study this, we set up an experiment to look at how people's movements looked when they made the decisions. And the most simple decision you can make is essentially some sort of a reaching decision, right? And in a practical way to study this, you can use mouse tracking. So essentially people sitting at computers using the computer mouse and making a simple, performing a simple decision-making task. And it has been shown that there is neurophysiological support for hand movements as valid indexes it's a valid index for evolving decisions. Mouse tracking is a fine-grained measure, or gives you a fine-grained measure of behavior. You can look at the decision microstructure, and you can capture somehow in-between states. It's commonly used in studies looking at categorical decision-making. It's also used in other cases. In this case, we let people do a value-based decision-making task, sort of a learning task instead. So this is sort of what people did. They had to make a choice repeatedly. It's like super simple task, typical choice task. We had 107 participants doing this task, so we have a lot of data. They do 180 trials, and they can sort of win or lose points, essentially. I won't go into the details of the exact task, but as you see here, we did not analyze all of the tasks. All of the trials. But you can just ignore that for now. That's just how it is. Right, and then we looked at how they moved their mouse, right, when they did this task. So they moved their mouse, and then they also took the mouse back to sort of the starting point. So they had to be at a starting point at every time. They weren't really aware of us, or, well, we didn't tell them that we collected mouse tracking data specifically, even though we told them afterwards. So we told them afterwards, and we also asked whether or not we can somehow use their data to, for instance, show in follow-up studies, to show participants in follow-up studies. But of course, I mean, we didn't really ask them if they had any ideas on whether or not we looked at the mouse tracking, because it was a little bit awkward setup, I guess. They have to move the mouse and back and forth, like usually you just click, right? But I think they just accepted it. Yes, and so for the mouse tracking data, so the setup means that we have somehow two paths, right, per decision. So we have somehow a decision path, and then they also have some sort of a post-decision path, or like a return path. These different paths were clustered. Well, very weird sentence, but they were somehow labeled. We clustered the paths, so we looked at whether or not there were like different types of paths. And we also extracted movement features for each path. And these movement features were related to different somehow types of features, right? So they look at how you move in your XY position, maximum, minimum. Yes, there's a question.
Yeah, when you clustered them or labeled them,
Yeah.
was that qualitatively or just sorry? Or was it based on some machine learning?
No, it's not machine learning, but it's a typical clustering method.
So quantitative.
Yeah, yeah. And these features also looked at somehow deviations from some other straight line, directional changes, time aspects, distance and speed. And here we just, what we wanted to do was to look at somehow as much as possible here. We didn't really, we expected differences in the movement paths, but we weren't really, we didn't really have any hypothesis on exactly where we would see these. You could have done that as well, but here we wanted to somehow just explore, like, are there differences? What do they look like?
Differences between what?
Yes, that's a good question, and maybe I should have put the slides in a different order. But differences of variables related to decision making, and I will explain them here. Because what we also did is that we could model the participants' behavior here and extract variables of interest. So we used a simple Bayesian updating model, and the good thing about this, or using such a model, is that, like, typically you could have used a very simple, let's say, simple reinforcement learning model to track somehow beliefs of participants. So just to somehow try to illustrate this, if you use a Bayesian model, then you get like a whole distribution of possible probabilities, and in this case probabilities that the choice that the individual is making gives you a gain or a loss, right? So will you win or not? So essentially what the model does is that it tries to capture the beliefs of the participant, each participant. The participant tries to make it or make inferences about the possibility that you will gain or lose something when you make a decision, or for the two choice options available, and then makes a decision. And the little red line there illustrates what would be the expected value of making a certain decision. So this is a probability distribution of a certain choice. You can also calculate the expected value, and in many models you only look at the expected value. Here we wanted to look at the whole distribution, and I will come to the reason why we did that.
Is this a distribution for the some actual state in the
Yes.
or is this just illustrative?
This is just to illustrate, but it could have been like an actual, right? So this is
The red line's the state, that's the expected value, and the distribution's the distribution of beliefs that the individual is inferred to have based on the model.
So let's say the participant, if this is correct model, right? If we assume that this is how people do it, then this could be the belief that the participant has that he or she will gain a point from a certain choice. So it's likely not 0, likely not 1, but it's somewhere in the middle, right? So you have some sort of a distribution of whether or not you will win or gain something when you make that choice.
By choosing left or right?
Yeah, or choosing blue or red, or whatever the colors were, yeah. But in the example, I think it's blue or red. So you have like 2 choice options, and then you have some sort of a probability distribution that you will win or gain something. And you sort of make your choices and try to track what happens. And also the probabilities in the task, they sort of change a little bit over time. So they have to like keep making choices, or have to somehow relearn, or sort of they have to track this probability because it changes. There's a simple choice function, and the model was fitted to individual data. And the reason we did this is, of course, because we could extract or somehow compute some variables that we're interested in. And I talked a little bit about like what could be of interest, like what is valuable information from an observer's point of view. Even though this is not an observational task, we have a sort of observational eyes on it, right? What we did is that we extracted 3 variables, or computed 3 variables per trial for the decision, or decision relevant variables. So this is choice confidence, and we don't have to necessarily go into exactly the details, but it's essentially like the probability that the choice you make is better than the one you don't make. We also looked at something that we called context. So essentially, what is the mean expected value of these 2 choices that you have to choose between? And this is largely affected by whether or not you're in a gain or a loss block here. So, but it can also vary a little bit depending on how you like what probabilities you believe underlie the different choices, right? And we also wanted to look at precision, essentially the inverse of variance. So how precise is your expectation of an outcome? In the return phase, or return relevant variables, we wanted to look at what the outcome of a decision was. So essentially it's like -1, 0, 1. And we wanted to look at the prediction error. So how well did you predict what was going to happen? So was the outcome higher or lower than what you expected? Also the absolute prediction error, as well as some sort of a learning variable, essentially how confidence changed. And these variables could have been other variables, I guess. And I think while doing this presentation, I was thinking that maybe we should throw in more stuff here, but we'll see. But these are the ones that we settled on from some sort of a learning perspective, or observational learning perspective. And what we then did is that we wanted to see whether or not these decision variables or the decision variables somehow could be linked to the actions or the movement patterns, right? So this is an example of how the movements looked. So this is just a subsample, and this is when after clustering. So we clustered we clustered the paths, and here it's in 2 different clusters. It's these 2 on the left side, C1 and C2, and we can, just so you're clear, so this is here in the bottom, there's a green little X, that's the starting position. The red cross to the left is the target position. So this is the choice that they always make, and in some cases when they made a right decision here, we've just flipped the data, right? So it's all just mapped, so it's supposed to, so the movement is always starting at the same point and always ending at the same point. But that's just how you somehow look at the data, right? And this blue X in the left is the choice that they don't make, right? Just to be clear. And we can see here that these two types of movement look very different. And then I also wanted to add, so this is just another way of illustrating the differences here. So this is the, over time, how these paths deviate from this most straight line here. So just a way to illustrate the differences of the two types of movements. And what we wanted to know then was whether or not these decision variables that we looked at, can they somehow be linked to these two types of movements? And we see effects of confidence and context on cluster type here. So higher confidence gives more of this sort of straight path, and higher context as well. We gives more of these. Context was this somehow how well you somehow the mean expected value, right, of the two choices available. Yes, and this is for just for the decision, right? So the decision path from here to here. We also, when we looked at these different measures, and I didn't mention earlier, but there were actually 29 measures we looked at. And we saw effects of confidence and context on all somehow types of measures, not necessarily all measures, but all somehow types, and I kind of grouped them, right? So measures related to deviation, the measures related to timing and speed, and so on. So for instance, we saw that higher confidence and higher valued context were linked to less idle time, and idle time would be like how you somehow stay still during the trial. It resulted in smaller deviations from the shortest path, and also smaller AUC, so area under the curve. And these measures are, of course, not independent from each other. Just wanted to be clear, right? Because the path is they're all interconnected in some way. Yes.
I'm not perfectly sure still that I understand what context means kind of in the context of cognition. And a related question, are confidence and context independent?
Yes, they're independent, yeah.
Okay.
Yeah.
So maybe what we can come back
No,
to
but
that. So can you
context-
distinguish between them?
Between the effects of them, or yeah, unfortunately not very well, because they go hand in hand quite a lot. There are like some measures that they differ in. So how, let me see. So, and the context, what it is, I mean, essentially, in this case, we had like a gain-loss block. So, a gain block would give a higher context just by itself, right? Because it's a winning context, so to speak, gain context. But in a specific trial, you could also expect, let's say, a very high probability of winning from one choice, and a high probability of winning from the other as well, right? So if you have like a high probability of winning of both choice options, then you would have typically a very high context. Sort of high valued context. Yeah.
The context was the average reward, right?
Yeah, average expected reward, yeah.
Exactly. So it's just the,
Yeah.
so when there's higher average expected rewards, people think less and act faster.
Yeah. So there's a small difference in how you, I think, if the context is like, if you expect a lower value of some sort, or let's say like a loss, then I think you have a tendency to be more on the left side, so to speak, in this. But I think that's more or less the only difference. So that as if people sort of avoid the other one. But I can't really say that it's like a huge difference, but it is a difference. So we can look at the post-decision actions. So this is actually when participants just return to the starting point. So this is actually kind of a boring movement to look at, but since we had it, we can still look at it, right? So there's no options here, right? They just return. And we can see when we look at how the data or the paths are clustered that there's a very small, or at least like a much smaller difference in these two clusters here than compared to the actual decision, right? So you see that this is a little bit bent a little bit, like that, and that's more straight.
Are
On the
these
top.
clusters the same as before, or is this a new clustering based on the return?
It's a new clustering based on, because it's different paths, right? So these are the return paths, and then we just cluster them, and then in the previous we clustered the decision paths. So they go in different directions.
But it could be that they were connected.
Yeah, you mean that how you...
Mm.
Yeah, you see it as a whole movement, you mean? Yeah, I totally agree. We haven't...
Did you check?
No, we haven't looked at that. But that's definitely something you could look at. Definitely, yeah.
Just to clarify, these are different clusters.
Yes,
So, okay.
because it's a different movement.
But it's the same people,
It's the same people, yeah.
but
Same.
we don't know that the people in C1 here are the same people in C1 doing the same trial. That's what it means for...
Yeah. Maybe I should have... Yeah, you could use different labels here. Yes, no. So this is the clusters for the return paths, and the other ones were the clusters for the decision paths. So it's different data, essentially. But you're totally right that you could cluster like the whole movement, definitely, and look at the whole movement. And I think this is... I will come to it later, but I think it would be interesting to look at just a combination of course, the decision and the return path. Yeah. Was there?
Is it the
question?
case that did you also flip here the ones that are
Yes, these are also flipped.
coming?
I
Could
mean-
it be that the bend is because is like if I'm returning from the direction that is maybe that's related to my handedness? Or how do you interpret the difference between being straight and being bent?
How do you mean interpret? Well, I mean in this case it would be drifting a little bit more towards the non-chosen target somehow. It's a small difference, but yeah.
So I
That's
guess
how I
the
would
question could be: is there an equal distribution between left target and right targets?
Yeah.
In the
It's all
two?
counterbalanced.
Yeah.
everything in the design.
Yeah, but I mean in the what ends up in the clustering?
Yeah, I mean definitely. I mean there's so many data points that yes. There's no...
So it's
A
not
lot of data points doesn't grant you that.
Well,
You
no,
have
but
to measure it.
I could look at it. I haven't looked at it, but it's in the paradigm like 50-50. I mean, people make 50-50 left-right decisions. Of course, not exactly. So I don't have the exact number right now. And
It could be that your cluster 1 is all the left decisions and your cluster 2 is all the right decisions.
Could be,
Something
could be.
worth looking at.
yeah, I could look at
Double
that.
checking
Yeah.
for sure.
And here we see weaker effects in general, which is not so surprising, I guess, given that this is just, how to phrase it, it's a very unimportant movement. They're not really sort of doing anything. We see some effects of prediction error on the cluster type. So higher prediction errors, so more unexpected or more positive outcomes than expected leads to C1. more often, more CF1 paths, or leads to, but they're linked. And when we look at these measures specifically, then we see effects of absolute prediction errors, which would be somehow surprise related. Right? Then we see effects on time and speed.
So that would be post-error slowing.
Something like that. Yeah. But in general, less, I would say. So here, for instance, like a higher absolute prediction leads to like a longer reaction time in general, or if you want to call it reaction time, but the longer time spent, right, and then longer idle time as well. So you take more time and you pause a little bit more. If you are more surprised, if it was more unexpected. So to conclude a little bit here, well, variables related to decision making and learning can be linked to features of the movement patterns that are associated with both the decision and some of the post-decision action. The most clear effects are during decision action, so confidence and context, linked to the directness of the movement, time-related aspects such as speed and pausing. We see some weak effects during the post-decision action, for instance related to absolute prediction errors that are linked to aspects of time and speed. And I would say that these findings are pretty perfect for an observational follow-up, using this data to look at how people understand them when they look at them. And essentially you could say, right, that this somehow possibly enables information transmission that's kind of beyond this somehow choice equals preference, can somehow add more information. And people are very sensitive, we know that, to nuances in movements. So hopefully they can understand this. So if we somehow look at the first question now, then the second step would be to look at this other question. So can an observer somehow perceive something while looking at these kinds of movements? Do they use these movements to guide decisions, or can they even somehow label these decisions? So if we look at this B study from the beginning, right? So maybe the test B can use, this is of course just super speculative, right? Whether or not bees also do this kind of have somehow movements that are related to whatever they know or don't know, right? And we have some minutes left, so let's look at what this data looks like. Let's perform a mini pilot, 4 trials, some 20 or so participants. You will see 2 decisions. I can do like this. The decision maker will always choose the color here, the yellow and the magenta color. Okay? And if you saw these 2 decisions, and then you had to decide whether or not to pick the yellow or magenta, which one would you pick? And I'm actually not expecting fantastic results here, but let's just test. At least it will give you like an understanding of what the data looks like. Yeah.
Were they told, or would you tell them to choose the side where it's not black, or is it just you have no idea that just many people would choose something?
No. So this is good questions. I will clarify a little bit. So this is actually, so I used the data, and then from the data I created this. This is not what it looked like when they did it. So this is sort of the only thing that's kind of similar to the original task here was the position of the starting position and the choice options, right? But in the data that we collected, I don't really know like what colors they picked here. So this is essentially, but if you would see these two, and then I just made this black, so it would be the same, it could be a different color, right? So this, at this trial, yellow is preferred over black, and here magenta is preferred over black. But, and from a choice preference perspective, you wouldn't be able to distinguish between whether or not you would pick the yellow or the magenta one, the pink one, because they're both preferred, right? But is there information in the movements, perhaps, that could guide you to pick one or the other, if you were facing like the decision to decide between yellow or magenta?
Will,
Yeah.
will we know if both of them made a correct decision, or will they both made a wrong,
Yeah.
Because I guess the movement would be having different signals. So is that supposed to be?
Otherwise it's trivial.
Huh?
Otherwise it's trivial.
Yeah, but I guess I would look for different things if both of
Yeah,
them
yeah.
were wrong, versus if both of them are
Yeah,
correct.
but that's what you're trying to guess.
Yeah.
He's right, if both are wrong, I want to pick the uncertain guy.
Yeah.
And if both are right, I want to pick the certain guy, I guess.
So they would be different, right? So
I mean, the keys here would be that if
It
you,
doesn't matter.
Yeah, then you shouldn't look at them at all.
No, but then
I mean, you
no
could
reason to choose any of them.
I mean, the case would be that if you're more
it's not
confident.
about picking the right.
If you know the
Yeah.
answer already, then
But
It's
Yeah,
not about
well-
picking the right one. It's about
Yeah, that's the
identifying a signal, right, in the movement.
Yeah,
so it's much more important to know whether it's the same person that is performing both movements.
So you're deciding whether you want to search
Yeah,
for
and
the
in
candy
this
there
case-
and there, and Carsten, he's looking for the better teacher. And I think this is the difference.
Yeah.
Yeah, and this is actually, so this is related to your comment there. It should be the same individual. In this case, it's likely not, because this is just, I just randomized, I just picked some paths, right? But if you would do this, I think you would definitely do same individual, definitely. Yeah.
In this case, since they're both on the right, wouldn't you also just pick the one that appears on the right? Because that's
It's possible that you would do that in this if you, and of course if you would do this as a whole study, right, then you would counterbalance this across. I do have like several trials, but we'll see. We only need to go through one, I think, if you don't want to do all 4 of them, because there are 4. And also, just before we start, just so you know, this is, which is maybe also related to your question, whether or not it's the correct answer or not. This is just the decision movement. I just didn't include the return movement, but you could do that.
So
Yeah.
what are the participants asked to do?
I'm asking you, because this
Yeah.
is you,
Yeah.
you're the participants, right? So you're supposed to look at this and think that it's individuals making some sort of a decision. And then if you were faced with the decision to decide whether or not to pick the yellow or the pink one, which would you pick?
So that's just what we are asked, not like
Yes.
which one is the prettiest or
No.
No.
which one is.
Which one do you think is
Lightest.
most likely the best one?
Yeah.
Just, I mean, you could, yeah,
But that's it then. Which one is most
Yeah.
likely the best one?
yeah,
The one to pay off,
yeah, exactly.
The one that pays off for me.
Yeah,
Yeah.
in some way.
knowing nothing about the people that have made the decision. Nothing.
Yeah.
But only seeing the movement. Nothing else.
Okay, first movement. Okay, I don't know. Which one would you pick?
Yellow.
Yellow.
How many would pick yellow?
It's prettier.
It's prettier. Okay, most of you. Interesting. Wait, I have to like keep track, but because you said yellow, I'll.
But it's hard without knowing the context also.
Yeah.
It's the
I mean,
first
definitely.
they see, or if it's the 100th they see.
It's just for fun.
You want to go through? I can also skip them. Shall we look at them?
One
One more,
Yeah.
yeah.
This is really interesting.
Can you say when you click?
Ah, yes, of course. Okay, I will click now. I think.
Oh.
Yeah.
Oh.
Yeah, sorry, the animation is a little bit off. But that's a good point there, because of course you have to know how long they wait, for instance, before they move. Yes.
Magenta.
Yeah.
Yellow, magenta. How many would pick magenta? Most people, okay. Shall I skip them? I mean, you can.
It's actually
This is also, and I said in the beginning, right? So this is, I kind of like this kind of data. You can play around with it a lot, I think.
Either use
So, if anyone like, I mean, this is a way to show also how the data, what the data looks like, and whether or not someone is interested in it. Just tell me.
Oh.
Okay. Sorry, and I didn't announce when I was supposed to click. I'm gonna click now. Okay, I don't know.
It's always magenta.
Yeah.
Would you pick magenta? Yellow?
Christian said. So.
You have to ask one of them, only one of them, otherwise. If you ask both.
I don't know, maybe it's a 50-50?
Magenta.
No,
Yeah.
magenta.
Have you asked a question? You asked two questions, maybe at the same time.
Yeah, who would pick yellow? Some would pick yellow, but most, who would pick magenta?
If he has time to sit
Yeah.
around like that, he must be confident.
Okay, I'll take the last one then. Okay, I'm gonna click now. Yeah, sorry, it's a little bit sloppy, the animation there. It should, of course, end at the target. I'm gonna push the button for the next decision now. Okay.
Oh.
Did you pick?
Are you gonna say
Yeah, I don't know. I was just wondering if anyone had like a clue.
yellow?
Yellow. Okay, who would pick yellow?
Yeah.
Most people. Okay. I'll stay with this one. Okay, I think you're right in 50% of the trials, meaning this is not enough to see any effects, right? Well, who knows? But these are just like four random trials or 8 random decisions that I picked, given whether or not they were whether or not they were confident or not confident. So 2 of the trials are in a loss condition, 2 of the trials are in a gain condition. And for each trial, there's one decision that's somehow supposedly confident, right? And the other one is supposedly non-confident. And of course, we don't know exactly whether or not they're confident, because this is just something that we extract from the model. So we don't know exactly. So maybe they don't, we should have also asked them whether or not they're actually confident. Which leads me to the next slide. I will very quickly go through it. Because as I said, right, there's many possible research questions to look at here, or the many possibilities. So, as I said, like, would we see the same effects if we asked participants instead? Like, what is your confidence? What do you expect to happen here? If they would somehow report these values or variables rather than us computing them, would we see the similar effects then? This would be a little bit messy, but yeah.
Why do you say the computationally extracted? Because if participants see exactly what we saw there,
Yeah.
then we see the actual action. There's nothing computationally extracted.
No. I would say in the study that I showed. So the result that I showed, and when we look at whether or not there are differences in how they move, depending on how confident they are, we don't somehow actually know how confident they are. We just assume that they're more or less confident. Assume is a little bit weak, maybe, but but of course we're not exactly sure how confident they are, or how confident they feel. Let's say. Someone? No? Yes.
Are you finishing before we get to questions?
Yeah. I was just wondering. I heard someone starting a sentence. But, and would the effects be similar if participants try to somehow communicate choice preferences, let's say? So in this case, they were just doing something and had no idea that this could possibly be used to observe by someone else at a different time point. Can you hide your preferences? There are other studies looking at this, showing that you can to some degree, but maybe not entirely. And as an observer, so when we looked at these trials earlier, or these movements, how good would we be to try to report, let's say, how confident the choice was? Maybe above chance, who knows? And here, could we combine like different movement and return paths, for instance, and how would that affect how we perceive a trial or a decision? What features are important from an observer's point of view? Can we somehow simplify a movement but still make it informative in some sense? Which is actually this point here. So let's say we use only the time-related effects, or like pausing. So if we have a completely straight line, but we include some pausing, or we vary how much the decision maker pauses. Like, is that perceived somehow? And of course, if anyone else has any idea on something interesting to do here, then please feel free. And then thank you, and questions. We've had some questions already, but